So everyone, please put your hands
Good.
together for the wonderful Sandy. Thank you very much.
Thanks very much, Sarah. So before I get into things, I'd like to begin by acknowledging the traditional owners from the lands that I meet with you from today. And for me, it's the Whadjuk people of the Noongar Nation, and pay my respects to their elders, past and present. I'm going to give you a bit of an overview today of some ways that we collaborate within CSIRO. So, for those of you who don't know, CSIRO is the Commonwealth Science and Industrial Research Organisation. It's Australia's national science agency, and we do a lot of different types of science, if you like, within CSIRO. And I will specifically speak to you about what mineral resources is doing. Mineral resources covers the whole value chain from discovery through to processing and then reaching into the value add processing or manufacturing within CSIRO. Oh, and we're not moving. Okay, we are moving. Let's see if I missed one. Nope. Okay, so how do we operate? At CSIRO, because we're not a university, we're not a government agency as such, we're some sort of hybrid in between. We do fundamental science, but we also do applied science. So we do every bit, all the fundamental science that we do is we look at it with the lens of do we think that this can be applied in some way into industry or into government going down the track. So here's some examples of the types of people that we work with. So we work with industry, we work with universities. We build new companies, so by spin outs, for example, spin outs of CSIRO. We worked with Australian government agencies. And we get our funding, we receive our funding from all different types of places, including the Australian federal government, but also small miners, large miners, exploration companies, small and medium enterprises, etc. We're all about translating research into commercial, okay? And so I'm going to just go through this very quickly with you, and then I'm going to give you a few examples of where we've done that. So that storytelling piece, I guess. And to do that, we have to we've realized we have to be very agile in the way we do that. Okay, we can't have one model because one size it definitely doesn't fit all. The reason why we want to translate research into commercial is that that's where we believe we can get some of our big impact. If we can uplift, say, the pre-concentration of ore within a at a site, or we can analyze gold in a better way, or extract lithium straight into a metal product, like at site. Then we're cutting out a lot of different steps. We're reducing in the end the amount of energy that goes into mining or extraction. And so it's going to be better for us environmentally and better for the community. So here's some examples of where we've done that. I won't go through them, um, but happy to answer questions on that sort of thing. But when we decide what we're going to do, what we try to do is we try to be guided by data. Okay, so we in CSIRO as well, we have a group called Futures, and we have a look at what people need, what their expectations are, what they want. So here's a couple of sort of semi-recent reports. One's the Australian Attitudes Towards Mining. This is a sort of a vertical study that's been going on since 2014. There's been 3 studies, and we can see within this, for example, that Australians are getting happier with mining because they understand that we need mining for the energy transition, is what's coming out of that. But we also look at the where the opportunities are for CSIRO. Or for Australia, we don't want to reinvent the wheel. We may not be best placed all the time to do certain things. It might be quicker, easier, cheaper to get to build in IP processes or get sort of information from other areas, regions of the world, or for other regions of the world to do things than it is for Australia to develop a new industry, for example. And so we look for opportunities as to where we can fill the gaps. And of course, from minerals to materials types of research that we do. That is sometimes a little bit dependent on geopolitical situations, and we can see that there are shifts as well that we have to be agile around. In terms of raw materials, critical minerals is a big one, obviously. Okay, so the Australian federal government sees this as really important, obviously, as to pretty much every government around the world right now. And so in Australia, our government put together this group, or this organisation called the Critical Minerals R&D Hub. It's run out of CSIRO, and it houses research between CSIRO, the Australian Nuclear Science Technology Organisation, so that's ANSTO, and Geoscience Australia. So we all have different strengths, and it's brought together the science agencies that work sort of in that mineral resources kind of belt, if you like, to solve the problems we need to solve for Australia around critical minerals research and development. And here's one of the examples of one of the projects that the 3 different government agencies are working on. Looking at Australian clay-hosted rare earths, these are not the same as the ionic clay-hosted rare earths that we see in China. And what we're trying to do is build a way to be able to extract, talking about phones, my phone's just ringing. So extract rare earths from these sort of novel clay deposits in a viable way. So, in an environmentally responsible way, and in a way that's cost effective in Australia for rare earth magnets. Okay, so here's some examples of where we do some engagement basically in the discovery side of the mining value chain. So, oh, sorry, not quite yet. So first of all, SME engagement in CSIRO. So small, medium enterprise engagement in CSIRO. CSIRO is part of our charter. We are required to work with small companies in Australia, or Australian small companies working overseas. And in the financial year 24-25, CSIRO engaged with 1,600 or so companies across all of CSIRO. So not too bad, really. And we're seeing a year-in increase on that every year by about 10% across CSIRO. We don't just do work for them. So often they will pay for research, some of that research, and we will co-invest, or we put in kind into that work as well. And sometimes we'll work with more than one company at once to solve a particular problem, and even commercialize that technology so that then companies can access it without CSIRO. We want companies to be able to access good science and technology with us. That's a big aim that we now in mineral resources. If you look at the graph on your right, I think this is the pointer. Okay, this one over here. So in mineral resources, the number of SME engagements in 2024 was 70. This year's we think it's going to be around 70 as well, but we think that it will increase up to about 84 in the next couple of years. In CSIRO, we have a program called Kickstart, and what that does is it puts some money towards this work with small to medium enterprises. And in mineral resources, in the last year, we've had about 6. I think they've all been in my team, to be quite honest. And they're a really effective way of building in research programs into small companies that otherwise would not look at research as a solution for their problem. And here are the examples. So an example of collaboration across 3 government agencies in Australia is our hydrogeochemical database. So we collect water from bores around the nation, and they're variably analysed. And for the last sort of 15 to 20 years, I guess, CSIRO has been QA/QCing the data that comes from these. We've collected a lot of this as well, and we have been looking after a database around these data. So what you're seeing now at the moment is basically sulfate. Now, the reason why we do this, and so we're mineral resources, remember, we do worry about people's health. So our Bureau of Meteorology in Australia is actually they are mandated to look after these data, even though CSIRO are doing it for them. Geoscience Australia as well around the water, so that's why we all do it together. But mineral resources itself, we're interested to see whether or not we can find any footprints of deposits in these waters. Now, if you look at the Jaguar example here, and look at Jaguar up here, the sulfates are low around Jaguar and it's full of gold. Okay, so what that's telling us is sulfur has gone into those gold deposits. So that this particular deposit was targeted based on waters. And so we look at this as a way of baselining geochemistry into industry. We can also use this to understand what the lithologies perhaps of different rock types are beneath cover in Australia. I don't know if any of you have been there. Being here, it's not very well exposed in terms of bedrock. So understanding what's beneath the cover is really important. Another thing that we do is we look at those free data sets that, so in this case, spaceborne systems or satellite systems. We work with the different satellite agencies around the world. We make sure that the data are calibrated in Australia. So we look after the different areas and devices that are calibrating these systems where we can collect data to calibrate the data coming from these systems. And of course, we process the data. We process the data to look for mineralogy. Again, in my team, it's primarily to understand whether or not we can map out subtle signatures for deposits. Now, if we look at the image on the left here, this is from the ASTA data. This is actually from 2014. I think, and you can see it's very stripy, not so good. On the right, we have the Prisma data, the Italian spaceborne system, much better coverage here. So the same area, different data, but in the one on the right, we can start to map out actual rock types. If we look at this region here in Western Australia, you can see the granites coming in through here, through this Prisma data. So very, very useful. If we start to zoom in on some of these areas, we can actually see that the coverage is really quite good in some of these regions, and we're able to see the mineralogy, in this case chlorite white mica ratio, aluminium sheet silica abundance, and we can look at different wavelengths, and we know that different wavelengths around these minerals means different things in terms of alteration footprints around deposits. So we know that with the ASTA data back in the early 2010s kind of thing, that we know that the release of the national maps around ASTA actually led to companies finding deposits. And so now we're working with companies and we are working with the state and the federal government agencies to produce seamless mineral maps across Australia, which can be used for agriculture, which can be used to track soil degradation, which can be used to look at areas of prone to flooding, etc., etc. To solve a whole bunch of different problems. And so this is a way that we're collaborating with at the national scale, and we also collaborate with companies at the local scale almost to get the best bang for the buck outside of, I mean, this is free data, but they don't know how to use it. So I'll get to, at the end, I'll tell you how we're serving this so you can see what we do to get it out there. Another thing that we've done in terms of collaboration is another example is that we've worked with probably 50 odd companies now around, we work with companies to test a hypothesis hypotheses that if you analysed the ultrafine fraction of soil in a particular way, you would get a better returns in terms of your geochemistry or more useful geochem analyses. And so this became our Ultrafines Plus technology, which we licensed to a small company in Australia called LabWest. LabWest has grown threefold, or two or threefold since then, largely based around this technology. And what this technology does is it sees things that that your run-of-the-mill multi-element geochem on a soil sample that's from, say, 20 centimetres down doesn't see, essentially. So it's finding those anomalies that normally would be missed. But we weren't quite satisfied with that. What we also realised was that if we look at these pictures over here, these are sort of maps. We've taken the lats and longs off because the data are confidential from here. But these domain map areas they're different parts of the regolith. So we know that the cover or the regolith forms in different ways. So if you have a stream sediment as opposed to overbank deposit as opposed to weathered rock, we're looking at, apples, oranges, bananas. Now, normally in a geochem sampling or analyses type situation, you just look at everything at once and go, this is an anomaly over here, but you're comparing too many different fruits, essentially. So what we did was we developed a system called Landscape Plus, and we're serving this at the end of this month through our XT portal so that people can access it. We've developed this so that we can analyse geochemistry from like domains at the same time, and we're serving it through a portal so that industry can get access to it. So we don't keep it to ourselves. It's not something just in a paper. It's something that is easily accessible. Okay, so just conscious of time. So moving on, one of the things that we often do is we take samples and we pop them on an SEM, a scanning electron microscope probe, and we try to understand what the geochemistry or the mineralogy is of that sample. That's really great, but one of these TEMA rounds in this case, or SEM rounds, takes about 8 hours to scan. From sampling to putting it on a scanning electron microscope might take 6 weeks because of preparing the sample and that kind of thing. And so it's really slow. So when you're working with industry and you're trying to develop systems for industry to inform their exploration or inform their mining or inform their curiosity, you can't sell them this. It just takes too long. So we've developed a system. So what we've done is we have taken the training to or 60,000 SEM rounds and millions and millions of spectra, and we've trained laser-induced breakdown spectroscopy spectra or system to be able to read those and to be able to return on-the-fly mineralogy as you drill. So we haven't developed the machine. This is an Allomission machine. We've developed software based on our knowledge and how these systems work. And so this is still in process, but this is an example where we have been collaborating with a company called Northern Star for 8 years. There are other companies involved as well, but Northern Star is a gold company in Australia in this case, and they have taken over quite a few of those other companies. As you can imagine, they're having a great time at the moment with the gold price. Now, if we look at base metals, one of the problems we're trying to find, say, nickel in this case, is that we know nickel is hosted in orthomagmatic systems, but it's like they're like finding a needle in a haystack, often nickel deposits. So we've developed a system that will tell you if you take a sample from an orthomagmatic system, will tell you whether there's sulfur in the system somewhere. We did that. We've done that with about 11 companies, and now with those companies and some other companies, we're looking at ways to vector towards where the actual deposit is within one of these systems. Now, we haven't commercialised this yet, but we are looking for possible commercial partners to take this out to market because we don't want to keep it. We don't want to do this work. We need to get this into reality. And this is an example where those companies have taken a risk with us to collaborate around a technology. This first company, Indicated Minerals for Nickel, this first project, Indicated Minerals for Nickel, ran over about 2 years and came up with a very, very, very positive results. So they don't have to take decades. Okay, so transferring tools into industry and community or even government, how do you serve them? We're serving them via a portal called Exploration Toolkit, or XT, basically. I think this is my last slide. But this is just one way of getting something out to industry or into government. Another way, as I've shown you, is to partner with companies, to spin out companies, to partner with other government agencies and put things out via other national platforms. So that's it for CSIRO.
Fantastic. Thank you so much, Sandy. That was absolutely excellent. Round of applause, everybody, for the lovely Sandy.